Intel. He's going to be doing a session here on edge computing and the epicenter of 5G service innovation. We have Rajesh, who's going to be doing our speech for us. Thank you.
Thank you. Actually, I'm good. So, I'm good. Yes. Thank you. So, what a friendly audience, right? Half of the people are from Intel. Couldn't have asked for anything better, I suppose. But I think they're recording, so we'll hopefully, I think there'll be a larger audience that looks at this presentation. So, who am I? So, I'm actually Rajesh Gadiyar. I lead architecture and systems engineering for the network platforms group at Intel. So, I'm the CTO for NPG within the data center group, and it's an absolute pleasure to be here. I had never been to this Quanta campus. It's just awesome, beautiful. So, what are we going to talk about? We're going to talk about edge computing, also referred to as, okay, I have some more audience now, which is great. Come on in. So, also referred to as intelligent edge, edge computing, multi-access edge computing, mobile edge computing. We are actually all talking about the same thing, right? All of those terms eventually sort of like map to some form of edge computing. So why are we talking about this? I think Gary touched upon this a little bit in his keynote. He was talking about new opportunities in the telco space. And I truly believe, and actually this is a larger belief at Intel, that the epicenter of service innovation, along with new business opportunities, it's really at the network edge, right? There's actually a lot happening at the network edge. Particularly fueled by the 5G transition that's upon us, right? So I think there's a lot of things going on at the moment. So we are not yet there for 5G, but we are sort of there because the changes to the network infrastructure is happening right now in anticipation for what will happen in terms of deployment of actual 5G services in 2020, 2021, right? But that investment, that overhaul of infrastructure is happening today. So what 5G does, and we'll actually talk about this a little bit, right? So what 5G does, it actually provides, it's a big change from LTE, right? So in terms of bandwidth, in terms of latency, in terms of spectrum, in terms of unlicensed spectrum. So there is a lot of on offer, which actually changes the paradigm, right? So GPRS and 3G were more about voice and maybe like some connectivity, data connectivity. LTE was about mobile broadband, right? And we started actually watching live sports somewhat, right? And 5G is going to take it to a completely different level. And one of the other things that is happening from an edge perspective is also sort of like this nice sort of like coming together of the cloud service provider and the comm service provider, right? And we'll talk about what that means also. I think that's a big change, right? Because up until now, the CSPs were a little bit of a threat in terms of the telco business model, and some of the telcos being relegated as basically a pipe provider, and also limited sort of like opportunity to make money. But I think the strategic opportunity here for the telco operators is because of the real estate that they own closer to the customers, closer to the enterprise. I think this rise of the edge is going to be a little bit different, and I think it will result in some interesting coalitions, some interesting sort of like coming together of the cloud and the comm service providers. Okay, so what I'm actually going to do is do three things here, right? I'm going to talk about why edge. That's the first part of my presentation. I'm going to talk about what is the edge, right? This mythical edge, because everybody talks about the edge. We'll talk a little bit about what is the edge, and we'll also talk about, or actually where edge, and then we'll also talk about what is Intel doing and what are we doing specifically in collaboration with Quanta, and why is this interesting? How are we actually enabling some of the edge applications, particularly from a rack scale and distributed cloud perspective? So that's basically what I intend doing, right? So talk about why edge, where edge, and what are we doing to enable that. Okay, so what do you see on this slide that is interesting? The big alphabet B, right? So it's actually top to bottom, it's all about billions of dollars. That summarizes it, I think, right? I mean, there's like lots of data sources, but I think the revenue potential that the edge holds, I think, in terms of, and these are sort of like not Intel numbers, right? These are basically what the industry analysts are putting out there, right? So $600 billion in new mobile services, $200 billion in new cloud services, lots of NFV revenue, right? So we are actually beginning to see a lot of good NFV deployments already. The last year and a half or so has actually shown us that NFV has actually gone from, hey, this is interesting. If only we could virtualize the network services to, hey, this is real, right? So I think it's beginning to happen. And then, yeah, the SDN market growth, right? And then video services. 80% of the traffic is video anyway in the network today. So lots of good opportunities, I think. And what 5G does in terms of opportunities is really a new sort of like kind of services, right? So you have things like industrial control, industrial robotics, which are actually highly sensitive to latency and jitter characteristics, smart cities and buildings, autonomous driving, VR gaming, retail, edge caching, CDNs. So a number of new things, right? So up until now, it was really like, a little bit of video edge caching kind of thing combined with voice. But think of like, what all of these new services are going to do in terms of enabling the new, what I like to call it, services economy. Okay, so the other thing about 5G cloud is really the capacity utilization strategy. So let's actually talk about this for a little bit, right? So one of the big challenges that the telco operators have had for a long time is really the capacity utilization, right? They always actually provision for the max capacity, and then what they find out, anybody knows like what a base station utilization typically looks like? It actually runs at less than 20%, believe it or not, right? And you think about that in the context of what the cloud service providers do, which runs at almost like, whatever, 75, 80% capacity. And you can see like where the challenge is, right? One of the challenges at least. And so what we believe actually 5G in conjunction with NFV does is it does two things, right? So NFV and the change that is coming around in the infrastructure, it's great because it actually helps virtualize network functions, and it actually helps solve some of the utilization problem and get a better total cost of ownership, right? And then the other side of the general ledger, right, the revenue potential, I think what 5G would actually bring about in terms of new services, it would actually boost up that side of things, right? And so we're at sort of like nice confluence. The edge is interesting because all these new services, and then NFV sort of like enables how to sort of like enable those services in a very interesting manner, how to move them around depending on what's the quality of service, what's the SLAs that are required from an end-to-end perspective. And together, I think what happens is now you actually begin to see a better capacity utilization overall. Right? So, and then specifically, I think I mentioned base stations, right? So which run at less than 20% of capacity. What we have been doing there is looking at new ways of deploying that access network with things like Cloud RAN and SD-RAN, which actually begins to bring a lot of stuff that used to be out there, the Christmas trees that you see when you actually drive around on the freeway, to more of centralized locations in the form of data centers, right? So you can actually then do the load balancing and get a better TCO advantage. Okay, so like I said, so 5G extends the cloud to multi-access edge, and NFV is a key enabler because now one of the things that as Intel we've been driving for the last at least 5 years, actually much longer, but over the last 4 or 5 years, we officially coined the term NFV, and we started the XCNFV movement and OPNFV and so on and so forth, right? And we've been actually at the forefront of a lot of like this network transformation, as we call it. And what that is enabling really is this homogeneity, which actually allows for the distributed cloud, right? So it's basically the same infrastructure that is used in cloud that we are actually bringing to the telco networks and the edge, and then all the way into the access. So what that basically does is now you have a distributed cloud, right? So it's you can actually have like a cloud that is closer to the enterprise. You've all heard about core, central office re-architected as a data center. So that's a cloud, and it's actually a nice place to have because that's the unique advantage that telcos have, right? So that is not something that you have many central offices in a city like San Jose, that the CSPs don't have that proximity to the customer. And And that actually has its unique advantages as we go into the 5G infrastructure or 5G deployment. Okay, so why at the edge? I think I covered a lot of this, right? So I talked about the fact that latency, quality of service, and the high level of interactivity for services like AR, VR, industrial robotics, industrial control, that becomes a very key factor. And so that's basically the reason for why have certain applications strategically actually placed at the network edge. And then you sort of like contrast that with the public cloud. Public clouds have their place, right? So public clouds have been a great way to scale the infrastructure for many of the enterprises, and that's going to remain. But now, as I was saying at the beginning of this presentation, right, you'll actually see some very interesting dynamics, right? So you'll have an AT&T and maybe a Microsoft Azure sort of like coming together because there is a customer, an enterprise customer like Walmart at the end of it that has a hybrid cloud with, let's say, Azure, and their pipe provider is AT&T. And now with the central offices turning into little data centers, there is an opportunity to now offer new kinds of services. And then what we'll see is like basically a service orchestration mechanism like ONAP coming into play that allows for these services deployed which scale across, like, depending on the SLA and quality of service requirements. You have some services enabled in AT&T's central office, and then other services can be basically moved over time or have the flexibility to go into the public cloud, right? So some very interesting sort of like things happening. And we see this across the board, right? I gave a random example of AT&T and Microsoft Azure, but we see this in China, we see this in Europe, like, all over the place. Okay, so putting compute where it counts. So what I mean by this is actually, people always ask this question: where is this mythical edge, right? So what is really a network edge? And in different contexts, actually, edge can mean a number of different things, right? So people are looking at, I'll show you some examples where edge can be at the base station. At the bottom of the base station, you have like a small cloud, a set of servers, where you can actually host a bunch of services. That is an edge, right? Now, others are looking at edge as, hey, from somebody like AT&T's perspective, I have all these central offices that I'm going to actually convert over to little data centers, and I could actually achieve the cloud scale by hosting applications at that central office. That's an edge, right? Now, yet others are looking at it as, hey, maybe I can actually I can do something in my regional data center if it's not a latency sensitive application, and that is an edge for me, right? All the way to somebody like cloud service provider like an Amazon or Azure at the other end, they might actually look at it as, hey, I can probably do edge applications even in my like cloud data center. So in reality, there is nothing like one edge, right? So edge can actually mean it can span all of these alternatives that you see here as labeled as edge 1, edge 2, and edge 3, right? So it basically starts from base station to the central office, to the regional POPs, to the telco data center, all the way. Okay, so if you then look at a couple of examples, anybody heard of a company called Vapor.io? So you probably heard of them, right? So they are actually located in Austin, and they're doing something interesting, right? So they are actually doing exactly what I said. They are actually placing a small cloud right at the base station, and the product is called Volutus, right? And they're doing that because it reduces the latency for distributed applications. But think about it. These base stations are actually deployed with full capacity in mind. They're utilized only 20%. And the fact that now they're actually placing a little data center where they can actually offer services, it allows them to then utilize that potential, that capacity that they have much more effectively and monetize that. Right? So awesome business model. And I think there's a few other companies I mentioned, Vapor.io, but there's like 3 or 4 others that I know of that are actually following this kind of business model. Okay, this is another interesting kind of usage model, right? So smart stadium. So this is something that Intel did, I believe, at the Wembley Stadium in London. Well, actually, this one is actually Arizona State. So this is an ASU football field, but we actually did something similar at the Wembley Stadium in London as well. And what we did here is like we had basically base stations hanging off of drones. of like going into a local cloud located in the stadium, and it was actually providing this unique experience for the people in the stadium in terms of all these kinds of different services, right? So live camera signals, instant replays, even navigation to the restroom within the stadium, right? So I think this was very interesting. This was actually in my backyard in Arizona, right? So for the ASU football game. So the possibilities are immense in terms of just making the network personal, right? And the kind of services that you can offer and be able to monetize it. At the end of the day, actually, everybody wants to make money. Okay, so the second part of this is actually NFV and SDN, right? So I think this is where a lot of emphasis is being put today, or actually over the last 2 or 3 years, because I think everything that I talked about in terms of the potential that 5G has for edge services and what is possible, it couldn't be done without transforming the network in a very fundamental way and getting the network functions virtualized and put on the standard server, right? So Gary talked about this, and this is where we actually collaborate very closely with companies like Quanta, because we really believe that I think that scalable infrastructure, distributed cloud, that homogeneity in the infrastructure that you get to cloud enterprise comms, I think is very fundamental in terms of how you actually enable this next generation of services with 5G, right? So what we have is things like compute, network, and storage pooled resources with rack scale designs, next generation network architectures, dynamic flexible networks, and then really a focus on services, because I think there's been a lot of focus on how you actually virtualize the network functions, how do you actually deliver the efficiency, how do you get a better TCO. But so far, there hasn't been enough focus on how do you orchestrate all this stuff, right? One of the key tenets of NFV is all about closed loop automation, and how do you actually collect all the telemetry, the real-time telemetry data, and be able to orchestrate end-to-end services, right? And actually there's a future vision of this that we have actually started working on, which is you have all this wonderful telemetry data that you collect, that you use for orchestration today, which is largely sort of like hard-coded policies. But what happens when you apply machine learning and AI to that? Right? If you created a training engine where you're actually training based on different kinds of alarms and failure situations, well, guess what? You can actually predict failures in the network and auto-adjust. You can move things around, right, automatically without having to send a technician. That is sort of like the ultimate vision that we have with all of this, right? And all of this, the vision I'm talking about is actually enabled by NFV. And so you start with what we have with NFV with a focus on getting to something like a rack scale design, standard infrastructure, but then the possibilities as we actually go into the services economy of tomorrow is actually very immense. Okay, so what are we doing from an Intel perspective? We are actually looking at these three value vectors as something that is fundamental to driving NFV and making the intelligent edge happen. We look at packet processing, because historically packet processing wasn't something that a general purpose compute platform would do. But if you look at like what Intel's done with our investments in DPDK, Data Plane Development Kit, and then working with the larger open source ecosystem with FIDO and Open vSwitch and so on, we've really actually taken that to a new level, right? So, and I'll show you some data. Where we are today is with our latest generation Skylake platforms, we can actually do more than 200 gigabits per second on a single socket Xeon server, which is like unheard of, right? So, and in fact, at Mobile World Congress earlier this year in February, we demonstrated a terabits per second router implemented on 4-socket Xeon platform. We of course did not say it was Pearly or Skylake CPU at that point in time, because we had not publicly announced that, but it was actually running on a Skylake server, right? So we actually did this in collaboration with Cisco. So a terabit per second virtual router, so it's not just forwarding data, but an intelligent router running on a standard Xeon platform, standard server, right? So that's what we've been actually looking at as a foundational sort of like enabler for NFV and SDN for packet processing. Service assurance. So it used to be very easy when you have sort of like an appliance router. You go to a company I won't name, right? the traditional router companies, and you go and say, hey, I want a 10 gig router. You get a 10 gig router, you place it in your network, and you get 10 gig performance. But what happens when you actually virtualize this router and you put it on a standard server? How do you actually make sure that you can deliver to that level of performance, that level of quality of service and SLA when you're actually trying to randomly put like multiple workloads on that server, right? So how do you actually deliver to the SLA and quality of service? How do you dynamically monitor what's going on in the platform, collect all the telemetry, and make intelligent decisions? So that's the focus of our service assurance effort. And we've always had really nice telemetry information in terms of what the utilization looks like for the CPUs, for the chipset, for the accelerators, for FPGAs, and so on. The problem up until now was that it had like different ways of how these things would get exposed to the application, which would make things difficult in terms of integrating this with the application. What we've done here is we've sort of like brought all this nice telemetry data together into an industry standard interface like CollectD. And then we've actually worked with the OpenStack community to create the right plugins into OpenStack. And right now we are actually working with communities like ONAP to bring all this thing that we are enabling from a resource orchestration standpoint all the way to the service orchestration layer. So when you actually create the next generation of edge services, you can do that with a full knowledge of what the platform capability looks like and in a dynamic fashion, right? Not in a static fashion. So that's our effort on service assurance. And then the last one is platform security, right? And I think all of you know why security is important because I think as we open up the platform, as we deploy more and more virtualized network functions on standard infrastructure, you have to actually make sure that it is not just that the platform is secure with a hardware root of trust, but all your data is secure. That data that is actually stored on the platform with encrypted storage, the data that is in use within the platform, and the data that is leaving the platform with like things like IPsec or SSL TLS, right? So encrypted when it goes on the wire. So that's been the focus of our platform security initiatives, right? So what am I trying to say here? What I'm trying to say really is, I think when it comes to NFV as an enabler for next generation of edge applications, we are actually, from an Intel perspective and working with the larger ecosystem, both open source community and our key partners, we are looking at what are the fundamental inhibitors that are actually going to be a challenge in terms of enabling the next generation of services, in terms of building that next telco infrastructure. And we are systematically going after actually solving all those problems. And Quanta has been actually a great supporter and a great partner in actually being able to accomplish that. Okay, so a little bit about why the programmability, flexibility, and density matters. Because if you sort of like, we have a lot of data now over the last year or so. We've actually taken a Quanta RSD rack. We have it in the lab, and actually Edwin from my team is here. He's been doing most of the work. I get the credit. But what we've been doing is basically, porting applications such as an evolved packet core, an EPC application, right, with MMES gateway and P gateway, and looking at sort of like creating all this like multiple instances and being able to scale this. Other applications like provider edge router, and we're trying to see what would it look like actually when you have like disaggregated pools of compute, storage, and networking, and how far can we scale? What's the TCO benefit is going to look like, right? And what we're estimating right now, based on the data that we have seen, is we can get up to 3.9x higher virtualized workload throughput and number of VMs, right, in terms of capacity. So that actually talks to the kind of benefit that we can get in terms of the network infrastructure by virtualizing and by disaggregating the network with a rack scale like design, but also actually how that would deliver a much better TCO for the next generation of services that we can build on this infrastructure. So here's sort of like an example of edge clouds, in case you're wondering actually what this stack would look like. So the idea is actually you have basically a rack with some amount of compute, compute network and storage. It's actually mislabeled, and then virtualized. And then on top of that, you can actually run virtual machines that can host different kinds of applications, right? So imagine in that stadium context, I want to actually have a packet gateway that needs to be located very close to that edge within the stadium, versus today, these packet gateways, this EPC is actually deep inside a telco network in a regional data center, right? So now, if I just want to take this packet gateway and put it actually as close to the edge as possible, so I can deliver to the latency and performance and the throughput needs of the application, I can do that very easily with an instance of this edge cloud that is placed right inside the stadium, right? So that's basically what we're talking about. We're talking about a homogeneous infrastructure, possibly a rack scale design that hosts things like a virtual RAN, multi-access edge computing gateway, distributed EPC or parts of distributed EPC like packet gateway, like I talked about, or even wireline access, right? So we've actually done a tremendous amount of work with cable providers, really looking at the cable head end with things like virtual CCAP, virtual CMTS with some edge QAM kind of capabilities virtualized and running in the cable infrastructure on this kind of a platform. So, so when we think about edge computing, it is not just mobile edge computing. For us, actually, it is wireline, it is wireless, it is cable infrastructure. Because at the end of the day, these services, I think they can use any kind of transport, and we want to actually make sure that one, it lands on a standard server infrastructure, so there is no special needs in terms of what you need to actually do to the infrastructure to be able to deploy a certain kind of a service. And from an application perspective, it is ubiquitous, right? So it basically just runs on the standard platform. Okay, so that brings me to the third part of my presentation. So I talked about why edge, I talked about where edge, and now what is Intel doing, and what are we doing with partners like Quantum, right? So this is sort of like our vision of how we look at our long-term evolution of the architecture in support of what we're trying to do for the network transformation, right? So we have three areas of focus. We have a scale up, because ultimately we want to deliver to the best-in-class performance per watt per dollar. That's a phrase, performance per watt per dollar, that I utter at least like 10 times in a day, right, in different meetings, because that's basically what we are trying to do. That's the value proposition that we deliver. And how we do that is like by improvements in terms of building a best-in-class network subsystem on a standard server platform. So you've probably seen, and I'll actually show some data, that there's been like almost like a 2.5x improvement just going one generation to our latest generation Poli platform in terms of how good networking works as a first-class citizen on servers, right? We're adding new instructions, we're adding new kinds of accelerators. We're just trying to actually make it networking first-class citizen and very compelling on standard servers. That's number one for us, right? Now, in addition to the scale up, how we actually deliver a better performance per watt per dollar, we are also scaling out. And this is where our initiatives like rack scale design make sense, right? So what we want to be able to do is disaggregate, build these pools of compute, networking, storage, and it can be anywhere in the network, and we should be able to actually utilize it to the full capacity by just moving things around, right? Depending on, with closed loop automation, depending on the behavior of network, depending on the needs for different applications that are coming up. Containers, I talked about, how you could actually, for the edge applications, you could be containerizing some of these applications, and those have to be brought up and tear down like very fast, depending on where the resources are. And so supporting this scale out, the notion of scale out, that is actually a key element of our strategy, married with scale up. And then, like I said, orchestration from an end-to-end perspective, where a service provider like an AT&T or Verizon just has the capability to go look up in their service design and creation in their OSS BSS environment and say, hey, Walmart wants to set up a new service, whatever that is, right? The CPE and SD-WAN. And they should be able to just pull up a catalog and say, okay, here's my 8 vendors that support this. Click, click, click. Just gets deployed within seconds. Versus having to send a technician, roll a truck, set up everything, which takes like, at least a few days to set up today. Right? So this notion of service orchestration and closed loop automation married with scale up and scale out, that's basically where we're going. Okay, so now my talk wouldn't be complete without like a little bit of marketing for Intel capabilities, right? So I just want to actually share like a little bit about what I said. We were actually treating networking and network applications as first-class citizens on standard IA platforms, standard IA servers. Here's an example of what we have done with our latest generation Skylake that launched in like a couple of months ago in July. What you see here is some fundamental re-architecting of what a server CPU and server platform looks like to be able to actually support really good networking performance. What does that really mean? So we actually went from a ring architecture, which was becoming a little bit of problem as the number of cores are increasing. So we are already well past like 20 cores now, right? And who knows, in a couple of years, we'll be like double the number of cores. So we actually fundamentally changed this to a fully architected, like a mesh architecture. What that basically means is now you're not going from a piece of code running on one core to another core. If that core is far away, you're taking a very high latency, and that wouldn't work for real-time edge applications. So what we did is basically created a full mesh. So you're deterministic at any point in terms of wherever the code is running in the CPU, no matter what the number of cores are, right? And we actually focused on the I/O subsystem. We used to have a single point where all of our networking subsystem was hooked off of. Now we have actually 3 separate points where there is no arbitration and there is no congestion, right? So we can actually bring in a fairly big amount of I/O and be able to do that processing on a standard Xeon platform. So innovations like this have basically given us the largest step function increase in performance from a memory and I/O standpoint, right? So I think a number of you guys have probably done networking and network applications. The 2 biggest determinants of network application performance is one is memory subsystem and second one is I/O subsystem. And what you see here is the biggest improvement in memory going back in our history, and the biggest improvement in I/O performance going back in our history, right? Which actually talks for the investments that we're making in terms of networking and the emphasis that we put on networking in the context of data center initiatives. This is, I won't actually, I thought actually I would just flash this because, people always say, hey, hardware, yeah, I mean, what's the big deal, right? It's really the applications that have to run faster. And what you see here is basically some networking applications. And these are sort of like a real measured performance, right? So what you'll see is applications like a router, right? So what you see here is like the router based on the FIDO VPP code is like 85% better, just going one generation within a year, right? 1.85 times better. IPsec, which is actually a critical sort of like way of how you secure the data that is actually going on the line, is 2.5x better, right? Within sort of like one generation. So these are some astounding numbers, and these are real measured numbers on our Pearly platform, right, which runs the Skylake CPU. Okay, so the story is not complete, like I said earlier, without sort of like some mention of service orchestration, which is how you. So we talked about a lot about platform goodness. We talked about edge services, but how do you actually really, deploy these services, right? So I mentioned like you can imagine a service provider like AT&T or Verizon basically going, hey, I want to deploy this service, pick up from like who the vendors are from a catalog, click, and it gets deployed, right? So one of the tools of choice earlier this year, AT&T open sourced their e-com software, and they worked with OpenO community, the China consortium led by China Mobile and Huawei and ZTE and a few others, and actually several other service providers like Reliance Jio, Vodafone, Bell Canada. There's actually a number of them. And they formed this community called ONAP. And Intel is a platinum member. Actually, I participate in the TSC from Intel. And this is one area where we are actually putting a lot of emphasis because all the work that the investments that we are making in terms of building that best-in-class infrastructure for network applications and networking, we want to actually make sure that those key capabilities are brought up all the way to the services layer so you can actually make the good use of those capabilities, those accelerators, those new instructions, and also keep track of dynamically of like how the resources are being utilized and drive a closed loop automation and end-to-end service orchestration. And so that's what we're trying to do with ONAP. And I'm actually happy that we are actually nearing the first release of ONAP that will be in November. But also the next ONAP Developer Summit will be held here in Santa Clara, hosted by Intel, right? So if you guys have an opportunity, it's on December 11th, 12th, and 13th. So we would actually welcome, have you guys there. It would be a good opportunity to listen into what's happening in the ONAP community. Okay. I just want to conclude, and hopefully we'll have a few minutes for Q&A. So, like I said, Network Edge is the epicenter of new business opportunities fueled by 5G. And we're going to actually see a lot of interesting things here over the next 3, 4, 5, 6 years, right? I think this is, I think many people have called it like once in a lifetime opportunity. I don't know if I'll go that far, but I think there's a lot of good, interesting things happening from an edge standpoint. NFV and SDN, and combined with end-to-end service orchestration. So these are the key enablers for edge applications, because you can't actually deploy the kind of services that we want to deploy with the traditional methods with the physical appliances. That would just wouldn't happen. And then our collaboration with Quanta, it's been amazing. Actually, we've spent like a couple of years now on the rack scale designs and disaggregation, and we've come a long way. So we have some really good collaboration and very good interest that's coming through. I think there's some demos outside as well. And this is really driving the innovation leadership for distributed cloud and 5G infrastructure. So with that, I'll stop and take a few questions. I hope I did not put everybody to sleep. It was after lunch. Okay, if there are no questions, I'll be outside. If you guys want to stop by and ask me something, I'll be happy to. And look forward to talking to you guys again. Thank you.
Thank you so much, Rajesh.